All right, in this question, giving the amount of advertising expenses in billions of dollars from 1980 to 1988. And they're asking us for the line of best fit model that represents the expenses since 1980. Now, before you begin, I want to call your attention to this bold text that says since 1980. That is extra important. The reason for that is because we are asked for years since 1980, we need to add a second row in the middle of the two rows we have now. And in that row, we are going to subtract 1980 from each of the years. So if you ever see the word since in the question statement, that's a clue that we must add a second row. So we will right-click on the second row and say Insert to put a new row in between. And we'll title this Years Since 1980. Now in the box below there, we will say equals the year above minus 1980. Now when we press enter, we should get 0. Excellent. Now let's go to the bottom right-hand corner and get the black cross. Now be careful when you do this, because if you're too far up, you'll get the 4 arrows. We don't want that. And if you move a little bit too low, you'll get the white plus sign. We don't want that. We want the black cross. We click the black cross, hold the button down, and move our mouse to the right to automatically complete the second row. So I'm going to make a note here that make sure you use the black cross on the formula. And that formula should say our year subtract 1980 in the second row that we made. Now that we've done this, we can go to Insert Scatter to create a new graph. So we'll select the bottom two rows with our year since 1980 and our advertising expenses. We'll go to Insert. The dots will be the scatter. Notice when you mouse over it, it says Insert Scatter. And the first option will be the one we're after. All right, so there's our scatter. And to find the line of best fit, we need to add a trend line. To add that trend line, we are going to right-click on one of the dots and select Add Trend Line. Right-click on the dot, say Add Trend Line. Linear is what we're after here, and we will tell it to display the equation. And it never hurts to display the r squared along with it, just in case they ask for it. They don't often ask for it in Math 143, but we'll go ahead and put it on there anyway, just for the sake of tradition. So our trend line says y equals 8.105 times x plus 53.52. So that's our model of best fit, keeping in mind that x is the years since 1980, and y is the advertising expense. And notice that it says that this is in billions of dollars. Now, it asks for the slope and y-intercept. Let's talk about the y-intercept first. So the y-intercept is our initial value. That is going to be the number that is not next to x. So if we go to the trend line, the number that does not have an x next to it is the 53.52. So we can say that our initial value for the advertising expenses is $53.52 billion according to our trend line. Now it also asks for the slope or rate of change. Now the slope is the number that is next to x. Now in our trend line it says 8.105. Now this tells us how fast the advertising expense is changing. So we can say for every year that passes since 1980, the advertising expense is increasing by $8.105 billion. So when they ask you to interpret the y-intercept is always our initial amount. And the slope is always how fast the amount that we have is changing. So think of y-intercept as initial and slope as rate of change. Now there's a lot of different ways of stating this, but the way I state it is for every x that passes, the y changes by whatever this number next to x says, 8.105. All right, now we're asked to complete a prediction value row that indicate what our trend line would predict. So to do this, we are going to go below the advertising expenses and make a fourth row. And in that row, enter your trend line. Your x values are going to be the years since 1980 in the second row. Because remember, when we made our scatter, it was the years since 1980 that we based it on, not the year itself. So when we make our predictions, we have to make our predictions based on this row. So just for clarity, I'm going to show the second row is x, third row is y, and the fourth row will be our predicted y. So I'll write that this is a linear prediction, and we'll enter the trend line that was given to us by Excel, equals 8.105 multiplied by the x, that's in row 11 here, add 53.52. This will give us our prediction for our 0, which is 1980 itself. Then we use the black cross to create predictions for all of the x values. And so there's our prediction row. We can see that the numbers we have are fairly close together. For example, our prediction in 1984, which is 85.94, is fairly close to our actual number of 88.1. So this is a mostly reliable prediction for those years. So we would say that the model does a pretty good job because the prediction is close to reality. All right, it's a good indicator because the numbers are close together.